Hi everyone, welcome to another Math in Mind production. Today we're going to be looking at the number line and seeing how numbers fit on there and just basically trying to build our overall number sense, number awareness, and help us put ourselves in a position that we can, when we start working with integers, adding and subtracting them, we're a little bit more comfortable and we'll be better off. So let's get to it. On this number line, we are asked to place these four numbers where they belong. Okay, so let's start with the positive ones. I think those might be a little bit easier. 5 and 1/4. So we know that the whole number is 5, so we have to go from 0 all the way to 5, and then there's a fourth attached to it also, so we need to go 1/4 of the way to 6. So if we broke this space between 5 and 6 into 4 equal parts, 1, 2, 3, and the fourth would be on 6. 5 and 1/4 would be this first quarter, something around there. I know it's not super precise, but this gives us a pretty good estimation. 7.33 repeating. So if you know from benchmark fractions, 0.3 repeating is 1/3. Or you can just think of same thing here. Start at 0, go over to 7. If we were to go from 7 to 8 and break that into 100 tiny little pieces, we're trying to look at where the 33rd would be. So if we think about that as a third, that's going to put us somewhere around there. Okay, now the harder stuff. 2.5. If we were going to put pretend this was a positive number. If we were going to do 2.5, we'd go to 1, 2, and then halfway, because the 0.5 means 1/2, halfway between 2 and 3 would be 2.5. However, this is a negative 2.5. So same idea. We start at 0, we go to -1, -2, and halfway in between -2 and -3 is where -2.5 stands. Same principle for -6 and 2/3. We're going to go to -6 and then 2/3 the way to -7. So start here, go to -6, and then 2/3. So pretend this space between -6 and -7 is divided into 3 equal pieces. 1/3, 2/3, 3/3. We're going to be at the second one. So 1/3 would be around here, 2/3 would be right around there. Again, this is our best estimation because we haven't measured this out. We don't know, how far 2/3 really would be, but that basically gives us an understanding. Okay. So last class, we discussed rational numbers, and if we look at the word rational, that kind of gives us a hint as to what it means. We see the word ratio in rational, and we know that ratio are really just fractions. So anything that can be expressed as a fraction is a rational number. Opposites. So if we're looking at the number line, opposites, it's like the same number, just one's positive, one's negative. It's the same distance away from 0 in either direction. So we could say 2 is the opposite of -2 because they're both 2 units away from 0 in opposite directions. So same distance from 0 on a number line, but in different directions. Absolute value. Absolute value again deals with this distance from 0, but that's all it is. It's any number you can think of, a number's distance from 0 on a number line, that's its absolute value. So let's say our number was -8. How far is -8 from 0 on a number line? 1, 2, 3, 4, 5, 6, 7, 8. It's 8 units away. And the way we show that with notations is we use these straight lines that are parallel and the number we're trying to find the absolute value of. So this says the absolute value of 8. What is that equal to? Well, it was 8 units away. I apologize, that was -8. So -8, the absolute value of -8 was 8 units away. Let's try this with a different number. How about 4? What's the absolute value of 4? And remember, absolute value means how far is this number away from 0 on a number line. So 4 is 1, 2, 3, 4 units away from from 0. I'm misspeaking a lot. So the absolute value is 4. So again, rational numbers opposite absolute value. These are all important vocabulary terms. So here's a question for you. Are integers rational numbers? Good question. Well, let's see. Let's think of an integer, any integer. I don't know, think of something. I'm going to come up with an easy one. Let's go with -3. I like that one. Anything that can be turned into a fraction or expressed as a fraction is a rational number. Can I write -3 as a fraction? I know from previous years in math that whenever I have a number that's not written as a fraction, I can usually just put it over 1 and it's a fraction. In this case, yeah. -3 divided by 1, same thing, same value. Yes, that is a rational number. So integers are rational numbers. Is 0 a rational number? Ooh, tricky question. So let's think of 0. Can I turn that into a fraction? You might be thinking, maybe I should do 0 divided by 0, but that's not going to give us a good answer. Something you should know is you can never divide by 0. That's kind of a rule in math. But what if I did the same trick that I did over here? 0 divided by 1. Well, guess what? 0 divided by 1 is still 0, preserving the same value. And yes, brings us right back to it is a rational number. Cool. So here we have a number line with some points on it and some different values. And you need to estimate the value of each point. So let's take a look at letter A. Well, that point seems like it's smack right there on -7. So that one's pretty straightforward. So letter A has a value of -7. B, same deal on -4. B's value is -4. Whenever you're plotting points on a number line, the position of the point tells you what its value is. So same thing with C. Now here's where it's a little tricky because you might be tempted to say -2.5. However, if we were to look at the other side, 2.5 would be over here between 2 and 3. So -2.5 would have to be over here between -2 and -3. So it can't be -2.5. Well, if I look between -2 and -1, and I think on the positive side, that would be 1.5. So this must be -1.5. 4 and 5, D looks like it's right in the middle, so let's call that 4.5 or 4.5. And E, now it's a little closer than halfway. Again, the directions say to estimate, so you could get a bunch of different responses for this one. We could say it's 6 3/4. You might say that it's 6.8. Some people said looks kind of close to 6 2/3. I'd say 2/3 is a little hair to the left, but still a pretty good estimate. So any of those would be acceptable. And then down here, the opposite is just flipping the whole thing around. So again, A was -7, B -4, C was -1.5 or -1.5. Letter D, the value is 4.5, and letter E, the value is, let's say, 6.8 or 6 3/4 is pretty close to 6.8, 6.75, something like that. Alrighty. So, think of a thermometer, and I don't know, most people check their phone these days and don't even bother looking at thermometers. They rely on the Weather Channel or something like that to look at the temperature. But way back when people did look at thermometers, how does it relate to a number line? So here's how. If you take a number line and flip it on its side so that it's vertical like this, you really get a thermometer. Zeros on a thermometer is usually a little closer to the bottom because usually you're never anywhere that gets too much colder than, you know, -50 or something like that. That's why it's not smack in the middle. However, sometimes it is. So again, a number line is really just, a thermometer is really just a number line that's vertical. So if we were to place these numbers, well, we'd know, you know what, let's go back and hide this. We know 0 has to go, let's not change. 0 needs to go somewhere, and beneath that is all the negative numbers, and then above that is going to be the positive numbers. So we'd want 115, that's the largest positive number, or the largest number in general. We'd want that at the top. And then we'd want 85 below it, and then we'd have 0 somewhere around here. And then let's see, we did 0, we did 115, we did 85. The next smallest number would have to be -3. So we'd have -3. Let's just do this quickly. Let's say 0's there. Let's just say, again, this is a sketch, doesn't need to be perfect. -3 is here. -7.5. And -15 is down here somewhere. 85. And I don't know, 115. Okay. Now we're prompted with two different situations. Let's look at this top problem first. It says determine which temperatures are farther from -2. So if you didn't have a number line here, if you were just given this problem, it's kind of hard to visualize in your head, right? I mean, if you're like me, seeing things really helps with your understanding tremendously. So if you were given a problem like this, a good problem-solving strategy would be to draw a number line out on your page. Then you can see, all right, here's -2. What is farther? Is +6 over here? Or is -6 over here farther away? I think when we see that this one's only 4 units away and this one is 8 units away, I think it's easier to see that +6 is farther away from -2. So again, use good problem-solving strategies in mathematics. Drawing things out is always a smart idea. You know, if anything, it just practices that skill. However, usually when you see things drawn out for yourself, that prompts other ideas and things to go off in your mind in a good way. So let's see. Number 2, what's farther away from -2 as the directions say? -7 here or +3? Aha. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, they turn out to be the same. These ones are the same distance away from -2. So that was kind of a trick question. Turns out they're the same. Hey, nothing wrong with that. You have to be ready for it. Sometimes that turns out to be the case. How about +2 and let's use a different color. +2 and -7. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so this one is farther away. Number 4, I think you can handle that one on yourself, on your own. Let's see. Again, same deal. Pretend this wasn't here. This gets tricky. You might go, oh, first one, piece of cake in between 0 and 10. I know what numbers in between 0 and 10. I'm sure most of you can just think about that one. However, when we start doing negatives, hey, gets a lot harder. Whoops. Okay. Let's use the number line and think of it that way. So here we have -5 and +15. What's in the middle? Well, if I pinch in 5 here, or like go in 5, and go in 5 from here, we have some kind of reference points, and then the middle of that would be 5 right here. I'm sure some people wrote out all the numbers and kind of crossed off one from each side until they got the middle. Not a bad strategy either. Okay, let's see. How about in between positive 5 and negative 15? Positive 5, negative 15. Let's see. It's 5 units here and then another 15 units. So that's 20 total units that I need to go. And half of that is 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle would be negative 5. All right. And last but not least, negative 8 and 8. Ooh, I like this one. Negative 8, positive 8. What's in the middle? I think it jumps out right away. 0. So I know we're not in chemistry yet, but you will be. And something you should know about chemistry is atoms have charges. Protons are positive, electrons are negative. And whenever you have a positive and a negative charge, they kind of negate each other and give you a 0, or a total charge of 0. So there are other situations like this, like I could give an example. If one month I gained 5 pounds, oh, that would be a bad month. But pretend I gained 5 pounds one month, and then the next month I was really good and I lost 5 pounds. So gained 5 pounds, then lost 5 pounds. Those two would kind of cross each other out and give me a total change of 0, right? I think someone said today that same could be true of finding $2 and then having to pay someone $2, right? Puts you right back at where you were, wherever that was, for a total change of 0. So that's it for today. We're going to be doing a whole lot more, and please check back here whenever you need. Bye-bye.